All right, check it out. 3.6 Solving Systems Applications. All right, we're on the final section of this unit, and what we're going to do is we're going to model the systems of equations, and then we're going to figure out which method is best to solve it. And then, of course, with any type of word problem, we're going to answer within context of the problem. All right, let's jump right into it. These few steps right here are some good ones to go by. Anytime you model an equation, the first thing you should do is define your variables. Before we model with one variable, now we are modeling with two, and we're actually going to model two equations. So after you define the variables, go ahead and model based on the key words that it gives you as far as choosing what type of operations. And then we're going to choose which method of solving works best for the scenario, be it substitution or elimination, and then of course provide your solution set, but do so within the context, right? So if it says how many hamburgers, write how many hamburgers. All right, so I got a few examples to get through. I'll try and make this quick. So our example number one, it says Melanie and Jill are selling cookie dough for a school fundraiser. Customers can buy packages of sugar cookie dough and packages of chocolate chip cookie dough. It says Melanie sold 3 packages of sugar cookie dough and 11 packages of chocolate chip cookie dough for a total of $217. Jill sold 11 packs of sugar cookie dough and 4 packs of chocolate chip cookie dough for a total of $178. So it is asking us what is the cost each of 1 package of sugar cookie dough and 1 package of chocolate chip cookie dough. So if we're asking for what cost of sugar cookie and what cost of chocolate chip, we should probably use these variables. Remember, you can use any variable you like as long as you define them. In this case, I'm going to use S for sugar cookie. So I would define my variable. This is going to be sugar cookie dough. I'm just going to do sugar cookie. And then I'm going to use C for chocolate chip. Alright, so this is me defining my variables. So C is for chocolate chip. Okay, then we go back and we look. What are our key pieces of information? Well, we got Melanie and Jill. Okay, we got 2 different people, and they're both doing the exact same thing. So Melanie is selling 3 packages and 11 packages, and she is making a total of 217. So she's selling chocolate chip and sugar cookie. Okay, then it looks like we have some sort of addition going on. I don't know how much the sugar cookie or the chocolate chip cost, but I know I have 3 packages of sugar cookie, so that would be 3 times S, right? And then I am adding the 11 packs of chocolate chip, so that would be 11 times however much the chocolate chip costs. And after I sell both of these types of cookie dough, I get a grand total of $217. Okay, then we also have Jill selling 11 and 4, and she makes 178. So if you haven't seen it already, we are going to model it just like we did the first one. We have 11 of sugar cookie and 4 packs of chocolate chip, and we are selling this for $178 total. Okay, so it looks like we have our 2 equations. We can go ahead and solve this. What would be the best way to solve it? Well, if we look at equation number 1, neither of these are common multiples of each other, so it'd be kind of hard to solve for a variable and not get a fraction. Same thing with the bottom, so our best bet here would probably be elimination. And if we look, can this smaller number go into this big number? It cannot. Can this smaller go into this bigger number? It cannot. So we are going to need to multiply both equations. So we are going to need to get one of these variables with the same value and opposite signs. Here we have all positive signs, so one of these needs to be a negative. I'm going to go ahead and get rid of our S values. So My lowest common multiple of 3 and 11 is going to be 33. So I'm going to multiply this top one by a negative 11. And I'll multiply this bottom one by a positive 3. And then we will rewrite these. So 3s times negative 11 is going to be negative 33s. Negative 11 times 11 is going to be negative 121c. And 217 times negative 11 is going to be negative 2,387. All right. Then I am going to add my second equation. We got 3 times 11s. This is going to be 33s. For a 12 plus 12c. And 3 times 178 is going to give me 534. All right, so let's go ahead and add these up. I get that 0 term there. Negative 121 plus 12 will give me negative 109c. And negative 2387 plus 534 is going to give me negative 1,853. We divide both of these by negative 109. And we get C is equal to 17. So we know that chocolate chip cookie, so chocolate chip, I'm just going to say Choco Chip, costs $17 per pack. Okay, now we need to go and find sugar cookie. So we can go ahead and substitute this 17 into either one of these equations. And I'm going to do that here. So I got 3s plus 11 times 17 is equal to 217. 3s plus 11 times 17 is 187 equals 217. 217 minus 187 is equal to 30, and I get a value of S is equal to 10. So sugar cookie costs, we'll just say sugar, and this is going to be $10. All right, so this is type 1. Okay, if we have these set up, this is how we model this if we got two people doing the same thing with two different variables. Okay. All right, let's go to example number 2. It says a boat traveled 63 miles downstream and back. The trip downstream took 3 hours. The trip back took 63 hours. What is the speed of the boat in still water, and what is the speed of the current? So here we're looking for the speed of two different things, so we probably should not use the letter S. I'm going to use the letter B for the speed of boat. And then I will use the letter R for the speed of the river. Speed of the river's current. Speed of river's current. Very good. All right. Then the other piece that we need to know, remember this is a distance problem, and our distance formula is distance is equal to rate times time. So let's go ahead and model this. Both of these are going to be distance, so they're going to be set up exactly the same. We have a distance of 63 miles. Okay, so this is 63 miles there and 63 miles back. For our trip there, we have 3 hours, and our trip back, we have 63 hours. Now, the only thing we need to figure out is the rate. Well, the trip downstream is with the current, right? The current is running downstream. So we have the speed of the boat plus the speed of the current. So we can use B plus R. All right, and then our trip back is still the speed of the boat, right? The boat is still moving, but this time we do not have the speed of the current, so we are going to do B minus R. All right, let's go ahead and do this distribution so we can see what our equations look like. So up top we got 63 is equal to 3b plus 3r. And then down below we have 63 is equal to 63b minus 63r. Okay, so looking at both of these, what would be the easier way to solve? Up top, we can divide everything by 3, but an easier one would be to manipulate the bottom equation, right? These all have the same value. We got 63 as these coefficients, and then we have this 63 here. So if we want, we can divide everything by 63, and we can get these variables by themselves. So we got 63 equals 63b minus 63r. I'm going to divide everything by 63, and I'll get 1 is equal to b minus r. Okay, then we can solve for one of these variables. I'm just going to go ahead and add this r to both sides, and I get r plus 1 is equal to b. Now that I have my variable b completely solved by itself, I can plug this into the other equation, right? So we use this bottom one. I'm going to plug it into this top one. So here, let me do this in green. So I got 63 is equal to 3 times b, and b is r plus 1, plus 3r. So here we got 63 equals 3r plus 3 plus 3r. I want to combine my like terms. So I got 63 equals 6r plus 3. We subtract the 3. We get 60 is equal to 6r. And then we divide both sides by 6, and we get 10 is equal to r. So we found the value for r. That's the speed of the current. We can actually plug that into here. Let me do that in purple. So we have 10 plus 1 is equal to b, and we get 11 equals b. All right, very good, not too bad. So now we have the speed of the boat. So the boat speed is 11 miles per hour, and then the current speed is 10 miles per hour. All right, so this is how we do the distance formula problems. First, figure out that you are using the distance formula, and then we add those values in, looking for our rate of going with the current and without the current. All right, we got our next example. This is a rectangle problem, so we need to remember the formula for perimeter, and remember that is adding up all the sides, or using this formula here, 2 times your width plus 2 times your length. This is a great way for us to set this up. So we know the length of a rectangle is 5 meters more than its width and has a perimeter of 82 meters. So our variables should be L for length, okay, and then we should probably use W for width. You guessed it. All right, so let's model this, right? We know that the length is modeled after the width, so we are using the width to tell us what the length is. And it says it is 5 more, the length is equal to 5 meters more than the width, right? So if I need the width and 5 meters more, I'm going to do the width plus that 5 meters more. Then it also gives us the perimeter, so I know the value for P in my formula. And then I have 2W plus 2L, because 82 is equal to 2 of the widths plus 2 of the lengths. And then fortunately for me, I already have the L completely solved for, so here I could just do substitution. So 82 is equal to 2 times W, right, plus 2 times my length, and my length is W plus 5. All right, so let's go ahead and crack this out. 82 equals 2W plus 2 times W plus 5 times 2, which is 10. We then have 4W plus 10 is equal to 82. Subtract that 10, we get 72 equals 4W. And then we divide by 4 and we get W is equal to 18. All right, very good. Now we can plug this 18 in for W. So for our length, we get 18 plus 5, and that is going to give me 23. So my length is 23, and what's our unit of measurement? Meters, so 23 meters. And my width is 18 meters. All right, pretty painless. All it takes is understanding how to set it up. The arithmetic was quite easy. All right, and then our last one, we have Albert's mom helping out the film club raise money for the upcoming festival by making tacos and burritos. She was able to sell a total of 246 items and she made $765. If the tacos were sold at $2.50 and the burritos were sold at $5, how many of each were sold during the fundraising event? So if we are talking tacos and burritos, we should probably use T for tacos, and then we can use B for, yep, you guessed it, burritos. All right, so we know that 250 times the tacos, right? $2.50 for tacos, plus the $5 for burritos, sold for a total of $765. We still need to figure out how to model our other equation. Well, we know she sold tacos and burritos, but we just don't know how many of each. But if she sold tacos plus burritos, we do know that tacos and burritos totaled up 246. So whether we know how many tacos or burritos, we know that the combination of both of them totaled up 246. So this is going to be another good substitution. So I'm just going to go ahead and rewrite this. I'm going to solve for tacos. So I would subtract this b from both sides, and I would get t is equal to negative b. Oops, it's kind of ugly. T is equal to negative b plus 246. Now let's plug this into our t back over here. So we got 2.5 times negative b plus 246 plus 5 times b is equal to 765. So this is now negative 2.5b plus 246 times 2.5, that is 615. And then we have plus 5b is equal to 765. We want to combine these like terms, so this then becomes 2.5b plus 615 equals 765. Minus the 615 from both sides, we get 2.5 is equal to 150, and 150 divided by 2.5, b is going to give me b is equal to 60. So it looks like 60 burritos were sold. So we can now plug that in. We got t plus 60 is equal to 246. 246 minus 60 is going to give me 186. So we sold tacos were 186, and burritos we sold 60, or Albert's mom sold, I should say, not we. We were not there. All right, so these are the types of examples that you might see on any of these mastery checks or exams. Please get to know how to solve each of these types by doing that practice, and I will catch you on the next lesson. All right, peace out.